Hello, this is Professor Esther Pearson, and welcome to Chapter 2, Graphical Descriptions of Data. Chapter 2 is in Module 2 of our online statistics class. The first topic we'll begin with is organizing data. When we organize data, we can look at a number of different methods to organize it. First, there's the ordered array, and that's an ordered list of the data from largest to smallest, or vice versa. Next, there's the distribution of data, and that is a display of data values that occur and how often they occur. It can be a chart or a table. Then we have the frequency of distribution, and that's a table that divides data into groups called classes and shows how many data values occur in each group, and that would be the frequency of the data occurrence. Lastly, we have frequency, designated with the letter F, and that's the number of data values in a class. Next, let's take a look at graphs. When it comes to graphs, they should be able to stand alone without the original data. The graphs must have a title and a label for both axes, and this way we can identify what the axes represent. When appropriate, a legend, a source, and a date should be included on your graph. Next, let's take a look at a data representation known as a pie chart. The pie chart shows how large each category is in relation to the whole. Here's an example where we can create a pie chart from the following information. We'll take a look at an example that deals with types of housing. For types of housing, we have an apartment, a dorm, a house, a sorority or fraternity house. And then we include the number of students residing in those types of housings. For an apartment, 20 students. For a dorm, 15 students. For a house, 19 students. And for a sorority or fraternity house, 5 students. Let's continue on with our example for constructing a pie chart using the example of the types of housing. First, let's take a look at frequency. For the apartment, we had 20 students divided by the total number of students in all of the housing, which is 49 students, and that would give us a 41% frequency. Next, we have the dorm, which is 15 students divided by the total number of students in all of the housing, and that would give us 31%. Next, we have 9 students in the house divided by the total number of students in all of the housing, and that would give us 18%. Next, we have the sorority and fraternity house, which had 5 students divided by the total number of students in all of the housing, which is 49, and that would give us a 10% frequency. We take those frequencies and multiply them by 360 degrees because there's 360 degrees in a complete pie or complete circle. So we take our frequency for the apartment, which was 41%, multiply that by 360 degrees, and that gives us 147. Next, we take the frequency of the dorm, multiply that by 360, and that gives us 110. Next, we take the frequency of our house, multiply that by 360, and that gives us 66. Next, we take the frequency of our sorority and fraternity house, multiply that by 360, and that gives us 37. Next, we can see we take those angles and divide our pie into those angles, and thus we've constructed a pie chart. Next, let's take that same example of types of housing and use that to create a bar graph. and so we're using the same data. From that data, you will notice that the bar graph shown is in descending order of largest to smallest. So that would be from the apartment number of students of 20 to the smallest number of students, which would be in the sorority fraternity house, which is 5. This type of graph is called a Pareto chart and is typically used with nominal data. So as we take a look at the bar graph, we can see the classifications along our x-axis of apartment, dorm, house, and sorority fraternity. Then on our y-axis, we have the number of students, and that is indeed the frequency or the number of occurrences, the number of students residing in each one of those types of housing. And so we have 20 for apartment, 15 for dorm, 9 for house, and 5 for sorority. Thus, we've constructed a bar graph. Now let's take a look at how we can create a side-by-side bar graph from the following information. So we still have types of housing, but in this example we have the number of students from Class A, and we also have the number of students from Class B. For the apartment, in Class A we have 20 students, and in Class B we have 13 students. For the dorm in Class A we have 15 students, and for Class B we have 24 students. For the house we have 9 students, and for Class B we have 6 students. For a sorority and fraternity house in Class A we have 5 students, and in Class B we have 7 students. So as we construct a side-by-side bar graph, we're representing the Class A students with a blue bar and the Class B students with a green bar. On our x-axis we have our classifications of types of housing, and on our y-axis we have the number of students from Class A in blue and the number of students from Class B in green. Thus we've created a side-by-side bar graph. Next, let's take a look at how we can create a stacked bar graph from the following information. So we're using the same data that we did previously, but instead of being side by side, we're stacking the bars on top of each other. And so we have our classification on our x-axis and our number of students on our y-axis. We have our Class A students in blue, and we have our Class B students in green. And so we have the classes stacked one upon another. With the stacked bar graph, it's easier to see that more students live in the dorms than live in apartments. Next, let's take a look at histograms. A histogram is a bar graph of a frequency distribution. A histogram has the horizontal axis as a real number line. The width of the bars on the histogram represent the class width from the frequency table and should be uniform. Note that in a histogram the bars should touch, whereas in a bar graph the bars are separated, they do not touch. The height of each bar represents the frequency of the class it represents. Now let's take a look at an example of how we can create a histogram from the following information. Here we have in the table data collected dealing with plasma screen TV prices. So we have our classes of prices, our frequency of purchase, our midpoint within the class, and then the boundaries of the class. We would note that the class, our first class, is $1,500 to $1,599, and there are 2 plasma screen TVs within that frequency. And then we have our midpoint. We can see the midpoint is found by adding 1,500 plus 1,599 and divided by 2. That way we get the half point or the midway point, which is 1549.5. Next, we take a look at the boundaries of the class. We can note that the boundaries are 0.5 on each end of the classes. So we would have 0.5 minus 1,500, and that would give us 1499.5. We would also add that 0.5 to the higher end of our class. So we would have 1599 plus 0.5, which would give us 1599.5. The same procedure is used for each one of the classes. Now you may ask, where is that 0.5 coming from? Well, what you'll note is when we move from one class to the next, we're moving exactly 1 unit or $1. So as we go from $15.99 in our first class to our second class of $1,600, that's exactly $1. So we divide that $1 in half, which would give us 50 cents or 0.5. That's where that 0.5 comes from. Here we can see as we construct the histograms that although we use the class boundaries to draw the histograms, it's appropriate to use either the class boundaries shown in the figure to the left or the midpoints shown in the figure to the right when labeling the x-axis. So as we take a look on the x-axis of price in dollars, and if we take a look in the y-axis on the number of TVs, which would be the frequency of TVs or the number of TVs, we can see that we've got our classes designated, and also we've got our bars created. Next, let's take a look at a visual representation known as the stem and leaf plot. The stem and leaf retains the original data, and that data is numerical data or number data. The leaves are usually the last digit in each data value, and the stems are the remaining digits. So here are the steps for creating a stem and leaf plot. Number 1, we create 2 columns. 1 column on the left for stems and 1 column on the right for leaves. Then we list each of the leaves that occur in the data set in numerical order. Next, we list each leaf next to its stem. Next, we create a key to guide interpretation of the stem and leaf plot. And number 5, the leaves may be then put in order, if desired, to create an ordered stem, leaf, and plot. So now let's take a look at creating a stem and leaf plot from the following information. So we'll use ACT scores, the American College Testing Scores data. In that data, we create our stem on the left and our leaves on the right, starting with the first data point, which is 18. So the 18 would be a stem of 1 and a leaf of 8. If we continue with this stem of 1, we see our next data point would be 19, a stem of 1 and a leaf of 9. We can continue on in this same way with our stem 1, 2, and 3, and then we add on the leaves, the remaining part of the number. Thus we've created a stem and leaf plot. If we just visually take a look at this stem and leaf plot, we note that we have created a key such that we see the 18 would be divided into 1 as the stem and the 8 as the leaf. In our second stem and leaf plot, it's an ordered array, so we're ordering the leaves from smallest to largest. What we should also note in the stem and leaf plot is the shape of it. From a visual representation, we can see the stem of 2 has more data points or data representation than any of the other stems. So we know that there are more numeric data with the starting value of 2. Next, let's take a look at shapes of distribution. And a distribution is how our data is spread out or laid out in a visual representation. First, we have uniform shapes of distribution. And for uniform, that's the frequency of each class is relatively the same. Number 2, for our symmetrical shape of distribution of data, the data lies evenly on both sides of the distribution. Next, for our skewed to the right, we see that the majority of the data falls on the left of the distribution. We can see the higher peak of data is on the left, and then it tails off on the right. For number 4, we see skewed to the left, so that's exactly the opposite of skewed to the right. And here in the skewed to the left shape of distribution, the majority of the data falls on the right of the distribution. So we can see the higher peak of data to the right, and then it tails off to the left. And that's where we get the term the tail of the data. That's the diminishing portion of the data. Next, let's take a look at some definitions. First, we have the time series when we're dealing with visual representations, and that's a picture of how data changes over time, thus the time series. Next, we can have a cross-sectional study, and that's a picture of the data at a given moment of time where we take a snapshot or a cutaway of the time, and that gives us a picture of the data at a given moment of time. Next, we have outliers, and that's a data value that falls outside of the normal shape of the graph. That's a data point that falls far outside of the rest of the data. Thus, it's called an outlier. Okay, so to kind of sum up everything, let's look at these two graphs shown below depicting the same data on people's satisfaction level with their local shopping mall. Which graph is more accurate and why? This will give you an opportunity to look at the mall satisfaction data for A and the mall satisfaction data for B. And as we look at these two depictions, we want to find out which graph is more accurate and why. That will give us an opportunity to analyze our visual representations. Let's take a look at that, make your decision, and also be able to describe why you made that decision. Just some brief comments. We see that we've got our months. The data was collected on our x-axis. And we have the percentage of customer satisfaction on the y-axis. We see that on the y-axis, the enumerations or the numbers indicating the frequency of satisfaction of these months has a different enumeration for mall satisfaction A and mall satisfaction B. Mall satisfaction A is enumerated in 0 through 100. Mall satisfaction for B is numerated in 0 to 50. Which one of these depictions of the same data is more accurate and why? Think about it.